Okay, now members, let us see how we deal with motions in resistive media. So motion that take place in resistive media, we use or apply in the second law of motion, obtain the equations of motion. So whenever like a falling body going down over there, those ones use Newton's second law. For example, let us see this example. A body of mass 1 kilogram is raised from rest and falls under gravity against the resistance of this Newtons, where S is the distance in meters that a body has fallen since release. Find the speed of the particle when it has fallen a distance of 6.4 meters. Okay, now we have a body, we have a particle of 1 kilogram. It's falling, but remember now it has, of course, what it's going to be pulling it down, it's going to be the weight, which is 1 times V to get the weight, to get the mass times gravity. Now this one is facing a resistance, but I'm telling us that this resistance is 7 over S plus 1. So that's the resistance it's falling. Now it's falling. They're telling us the distance in which it's falling is 6.4 meters. That's where it's falling. Okay. The distance that this particle is going to fall in. Okay, so they are telling us that find the speed at which this part of the particle when it has fallen a distance of 6.4 meters. So know that from our FR equaling m times f, remember it's going downwards. That's where the acceleration is acting. So also resolving downwards, our resultant force is going to be G minus the force that is opposing, which will be 7 over S plus 1, which will be equaling to the mass, which is 1 times acceleration, which is A. So from there you can set our G minus 7 over S plus 1 is equaling to A. But note, our A, remember our A is equaling to dV dt. But now, we say now we don't have anything like t and time. So we introduce velocity here. How? Our A will be d dv because we have distance. Then times ds dt. Now, we know that this one, the whole of this is velocity. Because our velocity is equal to the displacement over time. As simple as that. So start this one is the same. So this one, it will give me the dt, which will be there. So start now my acceleration is going to be dv ds times v. So from there, it will be v dv ds. Remember now they told you that now after this we come and substitute in there. So they told you that my v let you give as 10. So I have 10 minus 7 over S plus 1 equaling to B dV ds. So from there what happens? What we are going to do, we are just going to separate variables. I take this beside. So from there you can see that now, okay, if I write this as V dV ds equaling to 10 minus 7 over S plus 1. So if I cross multiply, so I'll be having V dV equaling to 10 ds. If I separate variables, this is going to go there, 10 minus 7 over S plus 1 ds. So after there, I integrate. So now after that, we shall integrate V dV equaling to integral of 10 ds minus integral 7 over S plus 1 ds. Of course, we shall get a constant of integration. This will give us b squared over 2. We'll integrate this. This will give us 10s, then minus 7 natural log of s plus 1, then plus the constant of integration. This one is standing in because this is the linear function, the s, and this is the linear function, so I'm getting natural log. So we need to get the value of constant c, the value of constant c. Now, you note that when it has covered zero distance, note that when it had covered zero distance, it means that even the velocity is going to be zero. Because as long as it has not covered any distance, it means that it's not moving at any velocity. So that's why I'm going to substitute here now. B squared over 2 will be equal to 10 into 0. Then minus 7 natural log of 0 plus 1, 10 plus c. Imply that minus is going to be 0. So implying 9b squared over 2 is going to be 10s minus 7 natural log of s plus 1. Okay, so they want us to get what? Now I want to get b when s is 0. I mean when s is this. So our b is unknown when s is equaling to the distance of 6.4 meters. So rb squared over 2 will be 10 into 6.4, then plus, this is the minus. So minus 7 into natural log of 6.4 plus 1. So from there, my b will be 2 into, when I cross multiply 64, then minus 7 natural log of 7.4. So there our b will be, when we get that onto a calculator, so it's that my b squared here is going to give me a value which is approximately 900. So what I'm getting it's going to be 99. If I round it's 99. Sorry, this is 99, not 9.9. Give me 99.9 793. So by b, we shall get the square root there, root answer, and we shall get 10 before we shall get 9, 9.9. 9.999 meters per second. So this is our velocity, but it's at all these we are given as scalars. So it's going to be our speed. So therefore, our speed is 9.999 meters per second. And so that will be our answer. So that's how we handle that. The idea here was, how do we, if you don't have anything like t, how do we remove this t? We bring in the idea. So here we are using chain rule. So after using chain rule, that's how we remove this, and we have the v, and then we have our a. So that's it, members. I wish you well.